Greetings, chemistry students. Today we are going to learn the parts of a balanced chemical equation. We're also going to talk briefly about the law of conservation of mass and why it's important for us to balance equations in chemistry. So if you take a look at the very first equation that you have on your CamiDoc or on your packet page, you'll see that we have aluminum oxide and 6 lithium fluorides, and that they combine to yield 3 lithium oxides and 2 aluminum fluorides. In this chemical equation, the arrow, which means yields, is dividing our equation into two parts. The compounds that are found on the left of the arrow are called the reactants, and the compounds that are found on the right of the arrow are the results, or the products. So when we mix our aluminum oxide with 6 lithium fluorides, we are going to produce 3 lithium oxides and 2 aluminum fluorides. A couple of other things to note on this in this reaction is that we have large numbers in front of some of our compounds. These large numbers are called coefficients. And we also have small numbers that exist within the compounds themselves. And you've worked with these extensively already. You should already know that the subscripts tell you how many atoms there are in the compound. These are subscripts. So the reactants are found on the left side of our arrow, or you could say they are before the arrow. These are the compounds you start with. Kind of like the ingredients in a recipe. The side of the equation that contains the products are those that are on the right of the arrow, or you could say that they are after the arrow. This is what results when you combine the reactants. So as I drew on the equation, a coefficient is a large number that is found before the compound formula. It is going to tell you how many particles are involved in the reaction. Finally, the last bit are the subscripts. The subscripts are the small numbers that are found after, that should be an A, sorry, A-F-T-E-R, that are found after the element's symbol in a formula. And they are going to tell how many atoms of an element are in the compound. Okay, now we're going to talk more about this later, but I just wanted to mention it here. There are 7 atoms, or 7 elements, I should say, that if they are alone in a chemical equation, they must have a subscript of 2. So if you notice, we have like oxygen is combined with aluminum, and fluorine here is combined with lithium. I'm not talking about that. I'm talking, what if we just have oxygen alone, like not combined with any other element? Or what if we have lithium alone? Well, fluorine. Fluorine and oxygen are 2 of the 7 elements that cannot stand by themselves. They have to be paired with another similar atom. So these elements that I'm talking about can be remembered if you remember the phrase High-Broncliffe. So for instance, if I want to combine hydrogen with oxygen to see what I'm going to get, I can't just have hydrogen by itself. No, it needs to have a subscript of 2. And how do I remember that? Well, hydrogen is a part of High-Broncliffe. So the formula for pure hydrogen isn't simply H, it's actually H2. Similarly, oxygen is also a part of High-Broncliffe. So oxygen can't stand alone either. It also needs to have a subscript of 2. So we're going to come back to this a little bit later, but I just wanted you to know that there are certain elements that cannot stand alone. Hydrogen and oxygen are 2 of them, but there's also, so let's see, hydrogen has a formula of H2. Iodine, its formula is I2. Bromine, its formula is Br2. Oxygen is O2. Pure nitrogen is N2. I just can't have an N standing by itself. It needs to have a buddy. It needs to have 2 of them, or they need to be combined with other elements in a compound. Chlorine, which is Cl, needs to have a subscript of 2, and then F also needs to have a subscript of 2. And so just keep this in mind, that there is a rule with some elements that cannot stand alone. So before we start talking about how to balance chemical equations, I just wanted to point out that the reason why chemical equations have to be balanced is because they have to reflect the law of conservation of mass. You see, mass is neither created nor destroyed in chemical reactions. The mass of any one element at the beginning of the reaction needs to equal the mass of that element at the end of the reaction. You can change the number, like the order or the combinations of different elements, that's fine. But if you start a reaction with 2 atoms of an element, you need to be able to account for 2 atoms of that element on the product side as well. And that is exactly how you can show that the mass of the elements on the reactant side is the same as on the product side. So for instance, if we take a look at an example equation, let's say this, H2 plus O2, when I combine those 2 together, I am going to get, I'm going to get 2 molecules of water. So if we take a look at this, you can see that I have 2 molecules of H2. So I'm going to draw an H2 molecule here, but I have 2 of them, which means that I have 4 atoms of hydrogen to start with. And over here, I'm adding it to 1 molecule of oxygen. Well, oxygen here has 2 atoms of oxygen. So I'm starting out with 2 atoms of oxygen, which means that on the product side, I should also have 4 atoms of hydrogen and 2 atoms of oxygen. Well, if we look at my product side here, you'll notice that I have rearranged the atoms. However, I have 2 molecules of water. So one molecule of water has 2 hydrogens and an oxygen. And my second molecule of water has 2 hydrogens and an oxygen. And if we count the green dots, I have 4 of them, which means I have 4 atoms of hydrogen. And if I count my pink dots, I have 2 atoms of oxygen. And if you look at what we wrote on the other side, you can see that we have 4 atoms of hydrogen to start, we have 4 atoms of hydrogen to finish, even though we rearrange them. Like water is very different from both oxygen and hydrogen. For example, water is a liquid while hydrogen and oxygen are both gases. But by rearranging the atoms, we are able to create a new substance, the liquid form of water. But we still have the same number of hydrogens and oxygens at the end as we did at the beginning. And that's what the law of conservation of mass says. So in order to follow the law of conservation of mass, we need to ensure that our chemical reactions are balanced. So let's take a look at what we need to do in order to balance chemical reactions. In order to balance chemical reactions, we need to add coefficients to the beginnings of each compound, which is why we have blanks here in front of the formulas for every compound. That is the only way that we can balance equations. We can't squeeze in like a 3 or something in the middle of a compound, and we cannot change any of our coefficients or any of our subscripts, because if we change a subscript, then we have changed the whole compound itself. So the first thing to know then is that to balance, you have to add coefficients. But before we just start adding coefficients willy-nilly, we kind of have to get a feel for how many atoms of each element we actually have in our chemical equation to start with. So what we're going to do is create what I call the grocery list. So that's going to be the second thing that we need to do. So number 2, so when we create the grocery list, essentially what we're doing is we're counting the number of atoms of each element that we have in all of our compounds. So to create the grocery list, I always draw a line below my arrow, and then I just go left to right, and I start on the reactant side always. So first I'm going to write my first element, which is lithium, and that is Li. Remember that abbreviations for elements always contain a capital letter, and most of them also have a lowercase letter. So that's how you can tell where the elements are in your compound formulas. And you can also check the abbreviations on your chem helper too, to make sure that you're not writing down the wrong elements. But on my reactant side, I have 1 lithium, and I know that I have 1 lithium because there is no subscript next to my lithium atom. And remember that just like in algebra, in chemistry, we don't write the ones. So if there's no number there at all, then you just assume that you have 1 atom of that element. So I've got 1 lithium. My next element is bromine, and that is Br. And again, I only have 1 atom of bromine because I don't have a subscript to the right of the element. My next element is potassium, and you'll notice that potassium has a subscript of 3, so I have 3 atoms of potassium there. And then my nitrogen, I have only 1. Now, I'm going to move over to the product side, but one thing that I want to stress here is that even though potassium is the first element that I see on the product side, that's not going to be the first one that I'm going to write. I'm going to keep the same order on my product side as I have on my reactant side, because then it's just really easy to compare left to right. Otherwise, you could get yourself mixed up and confused. So just make sure that you've got all the same elements on the right as you do on the left. All right, so on this side, I have 3 lithiums. I have 1 bromine, I have 1 potassium, and 1 nitrogen. Okay, now I can start to add coefficients. So again, I just prefer to go left to right. So I usually come back to my reactant side and I start at the beginning and I look at my very first element, which is lithium. Lithium has 1 on the reactant side and 3 on the product side. Now the thing is that when you're balancing equations, like there's nothing I can do to remove lithiums from the product side. Like I can't just make this 3 a 2 or a 1 or anything like that. No, instead what I have to do is I need to add a coefficient to the beginning of the compound that contains lithium. So if I want 3 lithiums on my reactant side in order to match the 3 lithiums on my product side, I need to put a 3 coefficient in front of lithium bromide. And then this is just kind of like the distributive property in algebra. So I'm going to multiply my coefficient by my subscript. So I'll write that down as step number 3. So multiply coefficients and subscripts in order to change quantities in the grocery list. So by putting a 3 in front of lithium bromide, 3 times 1, which is what I wrote here, is actually 3. And so now that quantity of lithium is going to change to 3. But 3 times 1 for bromine is also going to change. So now my bromine is going to change to 3 as well. So when you put a coefficient in front of a compound, you're changing the amounts of all the elements in the compounds, not just the amount of the first one. Okay, so now I see that my bromine has 3 on my reactant side, and if I hop over to my product side, I see that it's only got 1. Well, in order to change bromine from 1 to 3, what number times 1 gives us 3? The number 3. So I'm going to put a 3 here, and I do this all again. 3 times the little invisible 1 that's next to my potassium is going to change potassium to 3. And it's also going to change my bromine to 3. Oh, wow. So I just glanced at my grocery list and look at what happened here. My lithiums are 3s, bromines are 3s, potassiums are 3s, and my nitrogens have remained 1s. Just by changing 2 coefficients, I am now balanced and happy. And so that's pretty much in a nutshell how you're going to balance a chemical equation. You're going to add coefficients to one side, see how they change the number of elements, and then you need to bounce to the other side of the arrow and see how those elements change. Okay, so let's try another one together here. So I have magnesium bromide and sodium phosphide. Those are my reactants, and I have sodium bromide and magnesium phosphide as my products. So let's start first by making our grocery list. So I'm just starting off on the left-hand side, and magnesium does not have a subscript there, so that means I have 1 magnesium. My bromine has a subscript of 2, so I have 2 atoms of bromine to start. My sodium has a subscript of 3, so I have 3 sodiums to start. And my phosphorus has no subscript, so that means I have 1 phosphorus. On the other side, I have magnesium and bromine and sodium and phosphorus, and notice that even though the order has changed in my compounds, I'm going to keep the same order on the product side of my grocery list as I did on my reactant side of my grocery list. And so now I have magnesium is 3, bromine is 1, sodium is 1, and phosphorus is 2. Great. So now I can kind of start comparing, and again, I always start on the left-hand side, so that's just how I'm most comfortable. So here I have 1 magnesium on my reactant side and 3 on my product side. So in order to change my magnesium to a 3, I first put a 3 coefficient here, and that is going to change my magnesium to 3 because 3 times 1 is 3, and it changes my bromine to 6 because 3 times 2 is 6. Well, now I want to look at my bromines. So on my product side, I only have 1 bromine. How do I get 6? I have to put a 6 as my coefficient. And remember, you're multiplying your coefficient by your subscript. So 6 times 1 sodiums is 6, and 6 times 1 bromine is 6. Now, if you notice, I have 6 sodiums on my product side, and I only have 3 sodiums on my reactant side. How do I get 6 sodiums on my reactant side? Well, what number times 3 gives me 6? That's a 2. So if I put a 2 here, that means 2 times 3 gives me 6 sodiums, and it means that 2 times 1 phosphorus gives me 2 phosphoruses. And now look at 3, 3, 6, 6, 6, 6, 2, 2. I am now balanced. Hooray! All right, now I'm going to have you try the next one on your own. So go ahead and pause the video now, try this one on your own, and then we will see how you did. All right, here is your answer for the last one on page 2. I hope that you were able to get that correct, and if not, be sure to ask me in class the next time you see me. I'm going to stop this video here and then start a new one so that we can look at some more advanced problems. Thanks for your work.